So if we can use electricity to make magnetism, then maybe we can use magnetism to make electricity. So what some of the early scientists did was they thought that maybe if we could use a magnet and use that magnet with a coil of wire to make electricity. So what they did was took the magnet and they put it inside a coil of wire, and then on a meter, now I've got a meter here that's got 0 in the middle, and just now that meter's reading 0. When the magnet's inside the coil, that's a coil of wire that's got 20,000 turns of copper wire on it. There's 20,000 turns of copper has been wound around that coil. And I put a magnet inside it and nothing happens. But watch. I'm going to pull that magnet out. Watch the meter. When I pull the magnet out. I'm going to put the magnet back in again. In. Out. In. When the magnet's in the field, nothing happens. When the magnet's out the field, nothing happens. But when you move the magnet in or out of the field, we get a reading on the meter. Watch. One way, and then the other. When you move a magnet in or out of a coil of wire, it produces a reading on that electricity meter. And it's only when the magnet is moving. The faster I move it, the bigger the reading we get on the meter. It goes one way, then the other. Electricity that flows one way and then the other is called alternating current. And we'll speak more about that later. And another smart guy thought up, well, see, instead of moving the magnet in and out of the coil, why don't we move the magnet inside the coil by rotating it? So I'm going to rotate this magnet inside that coil of wire just by rotating the shaft of wood that the magnet's stuck onto. Just rotating it. Watch the reading while I rotate it. I'm rotating the magnet inside that coil. So by rotating the magnet inside the coil, we are producing a continuous alternating flow of electricity. And that is how all electricity is produced in modern power stations, by spinning a turbine. The turbine's connected to a generator, and the generator is a magnet spinning inside a coil of wire, and that spinning magnet produces a continuous alternating current in the coil. So if you move a magnet inside a coil of wire, it generates electricity. But surely we should be able to do the opposite as well. If you move a coil of wire inside a magnet, we should get electricity. So that's what we've got here. We've got a little coil of wire which is attached by this rubber band to this wheel. And if I spin the wheel, then it spins the coil, and that coil is inside that magnetic field produced by that big magnet there. Now if I turn it around, there's a little light emitting diode on it as well, a wee light. Now, there's no battery here. There's no battery involved in this whatsoever. All I'm going to do, I'm going to spin the coil inside the magnetic field. See what happens. That's magic. Now here's a slightly more mechanically advanced one. Little gearbox on it. Up, spin the dynamo, generate electricity. No batteries. Just plugged in. Just the energy of the movement of your hand. Spins a magnet inside the coil of wire. Generate electricity. That's magic. So that's really what goes on in every power station in the land. A generator is just a magnet that is spun inside a coil of wire, and when you spin that magnet, you generate electricity. And the spinning motion comes from, well, it might be water running down a hill, it might be a wind turbine, it might be burning coal, oil or gas to make steam to spin a turbine. But you have to get a spinning magnet inside a coil to generate electricity. And the faster it spins, the more electricity you get. The bigger the magnet, the more electricity you get. The bigger the coil, the more electricity you get. Now, once electricity is generated in power stations, transformers are used in the distribution process. This is so that energy gets sent efficiently around the country and eventually it reaches your house at the correct voltage. And you need to know the basic construction of a transformer and what it can do in stepping up or stepping down a voltage. Now, the last little application of magnets and coils and electricity we're going to look at is transformers. If we take a small coil, this coil here's got, well, a total of 60 plus 60, it's 120 windings on it. So wire has been wound round that a total of 120 times. And here's another one, it's got a total of 2,400 windings wound round it. If we put these together, now we're not going to connect them together, we're just going to place them together. And you put an iron core through the middle. And then we clamp that core. Using this little clip here just to clamp them. So, what we've made there is a little assembly that's got one coil on this side. The first coil is called the primary coil. The second coil on the other side is called the secondary coil. And the core running through the middle of them is just called the core. Now, that thing there is called a transformer. And what a transformer will do is it will change the size of a voltage. That's what that word transform means. If you put in a small alternating current on this side, or a small voltage on this side, that's a small coil, then we can transform it into a big voltage on this side. It has to be an alternating current going on this side though. A changing alternating voltage on this side can be transformed into a changing alternating voltage on this side, a bigger voltage, depends on the size of the coils. And transformers are used for transmitting energy around the country through the pylons, through the overhead wires. Transformers are also used when you charge your mobile phone in the wall. It's a big voltage from the wall that has to charge your mobile phone with a small voltage. So you go the opposite way. You go from a big coil down to a wee coil. You have a big coil as your primary coil, a wee coil as your secondary coil, and you can step a big voltage down to a small voltage and charge your mobile phone with a transformer. Transformers are very, very important then in electricity if you want to change the size of a voltage, either from very big down to very small or from very small up to very big. And they've got applications all over the place. That's transformers, not robots in disguise. Transformers for changing the size of a voltage.